still looking at simplifying radicals, but now we're going to add some operations onto it. So multiplication, addition, subtraction, stuff like that. So you can use the product and quotient properties to multiply and divide some radicals. So here I have two examples of multiplying radicals together. So if I have a number or constant on the outside of that radical, you can just multiply those together. So I have 6 times 4. That's 24. And then whatever's on the inside of your radical in that radicand, we can also multiply those together. Okay, so we have the square root of 8 times 2 is 16. Then we have c cubed times c. Okay, if I'm multiplying variables, you add their exponents. Okay, so that would be c to the 4th. And then d to the 5th times d cubed. So 5 plus 3 is 8.
Unless it doesn't, there's the like, if you're multiplying, say the 2 c's, like, would that add another exponent? Like, would that add one to the exponent?
Like this?
Like c times c.
C times c is just c squared.
Yeah, so then would it add on, like, one more thing?
Well, I have c cubed, which is 3, and c to the 1st, so I add 3 plus 1 to get 4. And then that's just what the answer is for that one. So from here, Austin, from here, I can simplify this root. Okay, so I can simplify this root. So if I need to, again, I can split that. So I have the square root of 16 and the square root of c to the 4th, d to the 8th. If you don't need to do this step and you remember how we simplified previously, that's fine. So I can take the square root of 16. Okay, that's 4. Okay, and if I have the square root of c to the 4th, what do I end up with? C squared, yeah. And square root of d to the 8th. D to the 4th. Okay, so I can multiply 24 times 4 to get 96. Then I have c squared and d to the 4th. So again, all we're doing is simplifying these radicals with different operations involved. So we just have one extra step. We have this multiplication first and then simplify your radical from there. Questions on A? All right, then we're going to look at B. So same process. If I have a constant outside my radical, I can multiply those two together. So I have 2 times 3 is 6. Okay, and then I can multiply my radicands together. Now this root is a 4th root. Don't forget that 4 there. It's a 4th root. So multiplying 8 times 2, again I get 16. X cubed times x to the 5th. Okay, adding your exponents together then. So I have 3 plus 5 is 8. Y squared times y squared gives me y to the 4th. Okay, again, I'm going to split this. So I have 6 times the 4th root of 16 times the 4th root of x to the 8th and y to the 4th. Can I take the 4th root of 16? Do you know? Yes. So I can take the 4th root of 16. It is just 2. So I have 6 times 2. Okay, and if I have the 4th root of x to the 8th, what do I end up with? X to the what? X squared. Okay, again, you just take your exponent, divide by your root. So then y to the 4th to the fourth root would just be y. Now, do you remember that thing that we did before, where if I had an even root and an even power and end with an odd, what do I need to add? Which one do I have to add absolute value to? The y. So I still have this 6 times 2 here. That's 12. And then I have x squared and the absolute value of y. Again, we do that because you had that domain error. Okay, so you have an even root, even power. I ended with an odd. Okay, y to the first is odd. So I need that absolute value around that variable. Okay? You with me so far with multiplication? Yes? All right, so radicals can be added and subtracted in the same manner as monomials. In order to add or subtract, the radicals must be like terms. Okay, so you have to have like terms just like you have like an x squared plus x squared. Okay, those are like terms, you can add them together. Radicals are like radical expressions if both the index and the radicand are identical. Okay, so here you have the square root of 3b and 4 times the square root of 3b. Your radicands are the same and your root is the same. So yes, you can add or subtract those together, okay, to get 5 square root of 3b, stuff like that. These are unlike, just because your radicand is the same on the inside. Okay, you have a 3b and a 3b, but your roots are different. Okay, I have a square root and a cubed root, so I cannot combine those. What are you looking at? Over here, these are also unlike. Okay, so I have the same radical, so both are square roots, but your radicand on the inside are different. Okay, I have a 2b and a 3b, so I cannot combine those. The only one I can combine over here is this first one. Okay, same root, same radicand. So we are going to use that to simplify a and b here in example 2. So the first thing I want to do is simplify the radical itself. So I can simplify the square root of 8. So I want to see if 4 divides into 8, 9, 16, 25, stuff like that, because those are perfect squares. Now I can split the square root of 8 into the square root of 4 and the square root of 2. Split it into square root of 4 and square root of 2. Because I can take the square root of 4, right? That is just 2, and then I leave the square root of 2. Okay, so that was me simplifying the square root of 8. I still need to bring this 4 back down. I'm going to do the same thing to the square root of 50. So when I'm simplifying square roots, I want to see if 4 goes into 50. Okay, 4 goes into 50. 9, 16, 25, 36. Okay, those are your perfect squares. Which one of those numbers goes into 50? 25. So I can split the square root of 50 into the square root of 25 times the square root of 2. Okay, I want to do that because I can take the square root of 25. Okay, so I still have this plus in between my two terms. This 3 still needs to come down. Next, I'm taking the square root of 25. Okay, so that's 5, and leaving the square root of 2. Okay, so these parentheses here are just the simplified versions of those roots. Okay? From here, I'm going to multiply my outer terms. So I have 4 times 2. That's 8. And then leave square root of 2. Plus 3 times 5 is 15. Again, leave the square root of 2. Can I combine these two? Is the root the same? is the radicand the same? The number on the inside, is it the same in both? Yes. So then yes, I can combine these. So I can add that number on the outside. So 8 plus 15 is 23. And then you still have the square root of 2. Okay, questions? All right, we're going to do the same thing in letter B. Okay, same thing in letter B. So I want to simplify the square root of 12. What two numbers can I split 12 into? What two numbers? 4 and 3. Okay, so then I have 5 times, I have the square root of 4, square root of 3. Square root of 4 is 2. And then leave the square root of 3. $27. What can I split 27 into? Two numbers. 9 and 3. Because I can take the square root of 9. So I would have this plus 2 still, times that quantity. The square root of 9 is 3. And leave square root of 3. The last one is 128. So this is one where you might not know the two factors. So what I would do is divide it by 4, divide it by 9, divide it by 16, 25, 36, 49. Okay, you see where I'm going with this? So that you have those perfect squares. So this one divides into the square root of 64 and the square root of 2. Okay, so that divides into 64 and 2. Because then I can take the square root of 64, it's 8. So I'm going to bring down that subtraction. Okay, subtraction. And then take the square root of 64 as 8 and leave the square root of 2. So we have 5 times 2 is 10 times the square root of 3 plus 2 times 3 is 6 times the square root of 3 minus 8 times the square root of 2. Can I combine any of these terms? Yes, which two? 10 and 6. Can I combine those two terms? No. Your number on the inside or your radicand is different, so you cannot combine those. So then this would be my final answer. Okay, questions on adding and subtracting those radicals. Okay, all you have to do is simplify the radical and then see if you can combine any. That's all you're doing for that. All right, then example 3, this is where we're going to FOIL. Okay, first, outer, inner, last. So I'm going to multiply my first two terms. So when I'm multiplying these two terms, I have 6 times 2. That's 12. And then I can multiply my roots together. So 3 times 5, I would get the square root of 15. Okay, so that was just my first terms. Okay, now I need my outer terms. Okay, multiply the number on the outsides. So 6 times 4 is 24. Then multiply your roots. So we have square root of 3 times square root of 2. That's the square root of 6. Okay, next moving to your inner terms. So negative 5 times 2 square roots of 5. So multiply that 5 and 2 together. So we're subtracting 10. And then the square root of 5 remains the same. And then my last terms, we have negative 5 times 4 square roots of 2. So that 5 and 4 multiply to get minus 20. And then we can leave that root 2. Can I simplify any of these roots? Square root of 15, square root of 6, 5, or 2. Could I simplify any of those? Does 15 divide by 4? No. Does it divide by 9? No. Does it divide by 16? No. So I cannot simplify that one. Okay, can I combine any of these? No. This is my final answer. Okay, next one we're going to do the same thing. So foiling, my first terms. So we have 7 times 7 is 49. And the square root of 2 times the square root of 2 is the square root of 4. Okay, then multiplying my outer terms. So 7 times 3 is 21. Okay, and square root of 2 times square root of 3 is the square root of 6. Next, I need my inner terms. So I have this negative 3 times positive 7. So that'll be minus 21. And then my square root of 3 times square root of 2 is the square root of 6. Then I need my last two terms multiplied. So negative 3 times positive 3 is my sign. Then square root of 3 times square root of 3 is the square root of 9. Okay, I can simplify this one. What is the square root of 4? 2. So I have 49 times 2. Next here, I have 21 square root of 6 minus 21 square root of 6. What happens there? They cancel out. Okay, then looking at my last term here, I have a minus 9, and then what's the square root of 9? 3. Okay, 49 times 2 is 98, and 9 times 3 is 27. Then I can just subtract the 2 to get 71. Okay, questions on letter B of example 3? No? We're good with foiling with our radicals? Yes? All right. Then I want to move to the other side here. So we're going to talk about conjugates. So binomials of the form a times the square root of b plus c times the square root of d, and a times the square root of b minus c times the square root of d, where a, b, c, and d are rational numbers, are called conjugates of each other. Okay, and I'm going to highlight that word here, conjugates. Okay, they are conjugates because you have these same terms here. Okay, a square root of b, right, in both, and c square root of d in both, but one's positive and one's negative. Now we do that to rationalize denominators. Now if you notice the example we went through on the front, these two are conjugates. That's why your roots canceled and you got a whole number. When you multiply by that conjugate, you should cancel out the roots just like we did in example B here. Okay, so that's what conjugates do. So we're going to do an example of this. So golden rectangles have been used by artists and architects to create beautiful designs. Many golden rectangles appear in the Parthenon in Athens, Greece. The ratio of the lengths of the sides of a golden rectangle is 2 over the square root of 5 minus 1. We want to use a conjugate to rationalize the denominator and simplify that fraction. So right now, we have 2 over the square root of 5 minus 1. Now remember, we don't want that radical in the denominator. That's why we rationalize it. So we want to multiply the numerator and denominator by its conjugate. Okay, so since this one is subtraction, our conjugate will be the square root of 5 plus 1. Okay, and we have to multiply that into the numerator and the denominator. Okay, so we're multiplying by that version of 1. From here, we're just going to multiply across. So in the numerator, I have 2 times the square root of 5 plus 1, and I'm just going to leave it like that. Over. We have to FOIL this out just like we did on the front. Okay, so multiply our first terms. Okay, square root of 5 times square root of 5 is the square root of 25. Okay, multiply your outer terms. Square root of 5 times 1. It's just the square root of 5. Your inner terms, I have this negative 1 times the square root of 5. So we have minus the square root of 5. And then multiply your last terms. So negative 1 times 1, you get negative 1. Okay, and we just want to simplify this denominator now. So we have 2 times the quantity, square root of 5 plus 1. I can take the square root of 25. It is just 5. Okay, then I have the square root of 5 minus the square root of 5. Those cancel. And that should always happen when you multiply by a conjugate. Okay, those middle terms should always cancel. And then I still have this minus 1 here. So I actually have 2 times the square root of 5 plus 1 over 4. What can I do with this 2 over 4? What? Change it to 1/2. So both of those numbers divide by 2. So that top one will become a 1, and that 4 becomes a 2. So my rationalized version here is the square root of 5 plus 1 divided by 2. Does that make sense? Were you with me through that problem? Okay, I tried to write down each step. Do you need to see the next one too, just as another example, to understand it? Yeah? Okay. So, in example 5, in a square with side A and the ratio of a side to the difference between the diagonal and a side is A over A square root of 2 minus A. We want to use a conjugate to rationalize the denominator and simplify. Okay, so we are rationalizing this denominator again. So I'm just going to rewrite that fraction. So I have A over A square root of 2 minus A. So what should I multiply the numerator and denominator by to rationalize that? Not just square root 2. We want to multiply by the conjugate. So I still need my first term, which is A square root 2, and my last term, which is A. But do I subtract those or do I add them? Add. So your conjugate, you have to switch your sign. Okay, when you're multiplying by the conjugate, you switch that sign. Okay, it's not the same sign, different signs. Okay, and I have to do that to the numerator as well. Okay, so again, we multiply straight across here. So we have A times the square root of 2 plus A. There's a lot of a's, but they kind of all cancel out, so bear with me. Okay, over, multiply your first terms. So we have a times a, that's a squared, and square root of 2 times square root of 2, that's the square root of 4. Your outer terms, we have a times a, so that's a squared, and then we still have it times that square root of 2. That doesn't just go away. Okay, then we are multiplying our inner terms, so negative a times the square root of 2. So that'll be minus a squared, square root of 2. And then multiplying your last terms. So negative a times a will be minus a squared. Okay, and then we just do want to simplify that denominator. So we still have a times a square root of 2 plus a. It's over. Okay, we still have a squared. We can take the square root of 4, right? That's 2. Our middle two terms are the same. Those cancel. And then I have minus a squared. Now I can simplify this a little bit more. In the numerator, what do both of these terms have in common? They have an a, right? So I can factor an a out. Okay, so I'm going to factor an a out of those two terms. When I do that, I end up with a squared on the outside. Right? Because I have an a, I factored out an a, so I have a times a, which is a squared. Now left on the inside then, I would just have square root of 2 plus 1. Okay, so I took an a out, it's in the front now. What about in this denominator? What do these two terms have in common? They both have an a squared, so factor out that a squared. Okay, then here I have a 2 minus I have a 1 left because I factored out that a squared. Now if I have a squared over a squared, what happens? They cancel. Okay, then I end up with the square root of 2 plus 1 over 1, which is just the square root of 2 plus 1. Okay, so when you're rationalizing the denominator, you need to multiply the numerator and denominator by that opposite sign between your two terms. Okay, questions?